Welcome back to architutors. In this ComfyUI tutorial for absolute beginners, where we'll build a workflow on how to generate a 3D model from just an image for any interior design object, we'll explore the basics of AI workflow in ComfyUI. To get started, head to Launch Cloud ComfyUI. If you're someone like me who doesn't have a mega system to run ComfyUI locally, sign up with any email. Once you're in, click the Launch Cloud option, and you're ready to go. What opens up is a visual canvas, very similar to Grasshopper, where you can build workflows step by step. On the left, you'll find menus to save, open, or export files. You'll also find a model library, where you can explore different models for your projects. Don't worry, I'll walk you through exactly how they work, step by step. There's also a Templates tab, which gives you access to pre-saved workflows. These are ready-made setups you can run instantly, and you can tweak the inputs to get different results.
It's a great way to experiment quickly without starting from scratch. But today, we're going to create our own workflow for an automatic 3D model generation. Once you've built it, you can reuse the same workflow endlessly. Just swap the inputs and you'll get fresh results every time. We can use any object image that we'll create into 3D object, but for this tutorial, I'm going to use an image of a chair. I'm going to simply save it into my device that I'll use in ComfyUI later. Okay, first in ComfyUI, double-click on the canvas and type Ksampler. Click on the result and drag the Ksampler component onto the canvas to insert it. This is the core node that takes your model, your text prompt, and your settings, then denoises random noise step by step into a finished picture or model. In short, Ksampler transforms noise into art. Next, let's add Load Image component. This is exactly where we can insert our image, basically that image of the chair we downloaded.
Now, also add the component Image Only Checkpoint Loader. That is a special node that loads just the VAE. It is a shortcut for swapping VAEs. It's like saying, keep the brain and translator the same, but change the lens through which the final image is revealed. Click on Checkpoint and define Hunyuan 3D as the checkpoint. Next, let's add Model Sampling Aura Flow component into our canvas. This is essentially a sampler node that controls how the diffusion model denoises latent noise into an image. Think of it as the flow controller for the aura or rhythm of sampling. Now we can add Clip Vision Encode component that is a node that takes an image as input and encodes it into Clip Vision embeddings. These embeddings represent the image in a way that can be compared or combined with text embeddings from Clip's text encoder. Connect the image input, and also let's change the crop value to none. Next, what we need to insert is the Hunyuan 3D V2 conditioning component in ComfyUI. That is part of the workflow for using Tencent's Hunyuan 3D model, a diffusion-based 3D generation system. This node prepares the conditioning inputs that guide the model during sampling. It's the most essential in this workflow. Next, let's add an empty latent Hunyuan 3D component. Just double-click on the canvas, type empty latent Hunyuan 3D, and drag it in. This node connects directly to the Ksampler input. It defines essentially the resolution of the output that will be produced. Here, let's connect the model and latent image outputs to Ksampler. Also, from the Hunyuan 3D V2 conditioning, we can take the conditioning outputs. Now we have all the inputs connected into Ksampler. The last step is to turn the model's internal latent image into a visible picture you can actually see. To do this, add the VAE Decode Hunyuan 3D component.
connected with the output from Ksampler. This is what transforms the hidden data into a voxel-based 3D representation. Next, add the Load Voxel to Mesh component. This converts a voxel-based 3D representation, like a grid of cubes or volumetric data, into a polygonal mesh, vertices, edges, and faces. Basically, 3D model. Now, to be able to preview the 3D model, finally, add the Save 3D Model component. This is where your generated model will be previewed, and from here you can export it locally to your computer. We can change the file name that it'll have. Connect the mesh input, and we have different options to change the appearance too. With these final nodes in place, your workflow is complete. Hit the Run option to run this workflow, and you'll see the data flow within components. And our model preview is ready. It looks super accurate, and it's hard to believe that we've generated that from a simple image input. It's highly detailed. In Options, we have an option to export this model locally along with other options we can change. We have 3 different formats we can download this model in, so 3D printing is also possible for these models. You can preview the model in different apps or even the web browser. This is the OBJ file that I'm able to preview in the browser. STL files can be opened in different 3D modeling softwares, including SketchUp, so you can use that into your design as well. So previously, we generated the 3D model using the surface net algorithm in Voxel to Mesh, but let's try the basic algorithm and see how different is the model that's generated. It's following a more simplistic geometry, and number of polygons must be lesser. So that's how we can build a workflow for 3D model generation in ComfyUI. Simple, flexible, and endlessly customizable. You can manipulate it to get different results, and all your outputs are automatically saved into the Assets section on the left.
This is how you can experiment with 3D model generation in ComfyUI with ease. Make sure to subscribe to architutors for more upcoming tutorials on ComfyUI and parametric design. Thanks for watching, and see you next time.